man, I forgot to change the number on this one slide. Now we're gonna make it look nice and pretty. Oh, there, look at that. That looks so pretty. Oh, we should make like color. Green? Dark or light?
Teal.
Teal. Isn't cyan like a red?
No, cyan's blue.
Yeah.
Turquoise.
That one?
Yeah. White.
No, we can't go white. White on a white background, come on.
Pink. Black. Brown. Yellow. White.
Maybe I gotta go. Okay, hold on. I gotta get it into that first, and then I can do. See, now I can go colors. That color right there.
Pretty.
So perfect. That right there, that is minute and 43 seconds of riveting introduction for whoever's watching on the line.
Are you keeping that?
Oh yeah. Oh yeah. All right, there's our warm-up problem. Let's do it. Tap the brakes. We gotta get through the warm-up problem first. There's a reason.
Are you sure?
Numbers never lie. How do I do this problem?
I know.
Talk to me.
So first you're gonna want to find a sub 1.
I would love to find a sub 1 first. What is a sub 1?
I got, well, a sub 1 equals 5 minus 5 times 1.
Okay,
Which is 0.
which is 0. Love it.
Then you're gonna want to find a sub n.
A sub n?
Yeah.
Okay.
Which I put 5 minus 5 times n. Which is 5 minus 5n.
Yep.
And you're gonna want to find n.
Okay, what's n?
I mean, I think for that part, it's just n minus start plus 1.
So that's,
N minus 1 plus 1,
so that's,
which is just n.
love it.
And then you're going to want to put that into the S.
The sum formula?
Yes. N over 2 times A1 plus AN.
Okay, so what's my sum?
It's negative 50.
It's negative 50. What's my number of terms?
I think it's just n.
It's just n. What's my first term?
0.
What's my last term?
I think it's 5 minus 5n.
Okay. Now what?
Just rewrite it just as 5 minus 5n.
Okay.
But
Can I multiply by 2 to get rid of that fraction?
yes.
Loved it. So that's going to be negative 100 equals n times 5 minus 5n. Distribute the n, you mean?
Then when you add up.
I'd move the other. I'm a big positive on my squared term kind of a person. Right? What's my answer?
When you put it back in, you see, or check back into the equation.
Does it?
I think it would just be 5.
Why?
Because aren't you just looking for the top, which is the number of terms?
Okay.
And you can't have a negative number.
Can't have a negative number of terms, can I?
That's impossible. So just do 5.
Your head should have hurt yesterday, though. Because there were 2 of those on your homework. Of the 5 problems, that was 2 of them.
Yeah, I know. I had a headache all day
Because of it. Yeah, I know. And it was so easy. Just had to think. Thinking shouldn't give you a headache. Thinking should clear your head and say, wow, Linz, this is a good problem.
Wow, Lynn, this is a good problem.
I sense your sarcasm. Applications today. What does applications mean? Word problems.
Oh,
You
no.
didn't throw stuff at me.
Sorry.
It's just word problems today. So I gave you the note sheet today because then that way you have the word problem written down and you don't have to keep writing down the word problem and not have to wait for word problems. See? Words. Yeah, I know. Guess what? They're all going to be solved with either a sum or a rule type thing. Great. Love it. A field house has a section where the seating can be arranged so that the first row has 3 seats. The second row has 7 seats. Third row has 11 seats. And so on. Or and soon, if you prefer. Okay. If there is sufficient space for 30 rows in the section, how many seats are in the last row of the section? And how many total seats are there in just that one section? Love it. Okay. Let's do some maths. So, it started out with 7 seats, right?
No, please.
3 seats. And then it went to 7 seats. And then it went to 11 seats. So our common difference is, oops, I almost put plus there. I want to put plus there. I missed the 7. Oh, rumba.
You put a 4 instead of 7.
Oh, that's why.
Oh, wait, yeah.
There, now it looks better. Okay. So how am I going to find how many seats are in that 30th row? You're going to want to write a rule, right? Yeah. So is it arithmetic?
Yes.
Yeah. So the rule for an arithmetic is a sub n equals a sub 1 plus n minus 1 times d. Do I have enough information to find the 30th row?
Yes.
Okay. So what am I going to do? A sub 1 is what? 3. Love it, because it's right there. I see it. First row. Oh. Plus, how many rows am I trying to find? 30. So that's going to be 10. Common difference D. 4, because we're going up by 4 every time. Well, what is 30 minus 1? 29. What is 29 times 4?
116.
116. What's 116 plus 3? 119. So in the 30th row, there is 119 seats. That's a big row. I would hate to be the last one in that row and have seat like 52. That's a
You
lot of.
forgot an S at the end of C.
Better.
Yes.
Yes.
How many total seats are there in that section?
What was summation notation?
Do we need to use summation notation?
Oh, we should.
We don't have to.
Just kidding, we don't have to.
Wouldn't we want to use the sum formula?
Yeah, that too.
How many rows are in the section? 30. What's the first
Three.
row have?
3.
What's the last row have?
119.
100 what?
19.
19. Sound like somebody said 118. I'm like, where are we at? 108 here. I don't know. So, $30, 119, trace. 30 divided by 2 is 15. Three plus 119 is 122. How many total seats are in that section? 1,830 seats. She didn't even see it.
Friends, that's so ugly. Thank you.
Oh, yeah. A production line. Here you go, my dear. It's a note sheet for today. A production line is improving its efficiency through training and experience. If the number of items produced in the first 4 days of a month are 13, 15, 17, 19 respectively, the project the number of items produced on the 30th day of the month. Project the total number of items produced for the 30-day month. Love it. Make it happen. All right, so we got 13, 15, 17, 19 as our sequence. Okay, we want to figure out the items produced on the 30th day. So we're going to start out with 13. Then we're going to go until we got the 30th day. And our common difference is 2. Okay. So 30 minus 1 is 29 times 2 is 58 plus 13 is 71. Total number of items that we produced during the month. Well, on the first day of the month, we were at 13. Due to efficiency and experience, on the last day of the month, we were at 71. And there were 30 total days in that month. So the sum of the first 30 days is going to be 30 divided by 2 times 13 plus 71. 30 divided by 2 is 15. 13 plus 71 is 84. 15 times 84 is...
1,092.
What was that?
1,092.
1,092?
What?
1,260.
That's what I got.
1,260? Sounds a whole lot better because it's got to end in a 5 or a 0. Because we're multiplying by 15. Do you understand that when you multiply by like something that ends in 5 or 0, it can only be 5 or 0? Good. I'd like to tell you that there's another example to do, but as you can clearly see, because we have a note sheet today, I'm out of examples. We do have a word sheet. It's yellow. You don't need to take a picture of it this time, Allison.